that x equals e to the power of 2t. Now, and y equals e to the power of t minus 1. So the straight line L passes through the points A and B. So A is where t equals ln 2, and B is where t equals ln 3. Well, if I know that, then I can work out x and y for A and B. So let's look at part A. X, therefore, is going to equal e to the 2 ln 2. If I simplify that, that is e to the ln 2 squared, which is e to the ln 4. And we should remember from our work on logs, e and ln sort of cancel out, and that is going to be 4. And y, therefore, is going to become e to the ln 2 minus 1. E to the ln cancels out, so I've got 2 minus 1, which is 1. So the coordinates of A are 4 and 1. And so if we look at now the coordinates for B, again following the same thing, x is going to equal e to the 2 ln 3, which is e to the ln 3 squared. Okay, just don't make a mistake on that part. That is a common area of mistake. We're going to have to use the power law and bring that to the top. And so we get e to the ln 9, which is 9, and y equals e to the ln 3 minus 1, which is 3 minus 1, which is 2. So we've got the coordinates now of B as being 9 and 2. Okay, any questions there? Does that make sense? Now, for part B and C, this is just standard coordinate geometry, which we don't need to really cover. Okay, you know how to do that. We don't want to waste time doing things we already know and are generally quite good at. Let's say x equals 2t and y equals t squared. So we now want to work out the gradient function. Let's say we just want to work out the gradient function here. Now, the thing is, there's two ways of doing this. One thing we could do is say, well, x over 2 equals t, so y equals t squared, but we know that t equals x over 2, and so we get y equals x squared over 4. So if I wanted gradient, I could say dy by dx equals 2x over 4, which is x over 2. Are we happy with that? Does that make sense how we worked out dy by dx there? So I worked out the Cartesian equation. And then I differentiated it using standard differentiation. Multiply the power down, take 1 away from the power. And now I've got the gradient of that graph. Now, another way of doing it is using the chain rule, which is often easier than working out the Cartesian. So how are we going to use the chain rule? Well, we've got a third parameter. What we can do is work out dx by dt. Can you please tell me what is dx by dt in the chat? When I differentiate 2t with respect to t, I get 2. So that's nice and easy. Can you please tell me what is dy by dt? So we know that as well, simple. Now I want you to get me a formula for dy by dx in terms of t. How are we going to get dy by dx? Using this and this. Tell me in the chat before you try it. Right, so if we think about it, we've learned the chain rule before. You know about the chain rule. Chain rule is simply multiplying or dividing different things until we get the thing we want. If we want dy by dx, I could say dy over dt divided by dx over dt. Because the process of division means I'll have to flip the second one over and multiply, cancelling the dt's out. So in this case, what I would do is say 2t divided by 2, which equals t. And that's it. That is why dy by dx in terms of t. And now, if I wanted to work out the gradient at any point, I would have to use dy by dx equals t and sub in t values. And that would give us a gradient at any given point. Okay, does that make sense? Are we happy with that? So this was just using the chain rule. It's not anything new that we are using. Is anyone confused? Would anyone like me to go over anything? All right, so I am going to start you off on exam questions on this straight away. So we are going to practice this. I'm going to give you about 4 to 5 minutes to have a go at part A. So this will bring in your differentiation knowledge from earlier as well. B, we basically doing parametric differentiation. In order to do that, I'm going to have to work out, first of all, dx by dt. Can you please tell me what is the differential of 2 cot t? Okay, so yeah, that's good. You should remember that cot t differentiated is minus cosec squared t. So this then becomes minus 2 cosec squared t. I've done that, nice and easy, nothing too bad. What do I need to be careful of when differentiating y, please? That it has this power here. So the best way to write this is 2, actually not here. I need to write this first. Before I differentiate that, I need to write y equals 2 times by sine t squared. Okay, please remember that. We need to put the powers outside for trig, otherwise we often forget to use the chain rule. Now we can use the chain rule. Multiply the power down, 4. Take 1 away from the power, so it becomes 1. What do I do next? Please tell me, what do I need to do next? Multiply by the differential of the bracket. Sine t differentiated is cos t. Okay, and then if I just write this as 4 sine t cos t. Okay, so now I've got dy by dx, I've got sorry, not dy by dx, I need to change that. Dy by dt. I've got dx by dt, I've got dy by dt. What I'm going to do next is to say dy by dx equals dy by dt divided by dx by dt. So now I've got 4 sine t cos t divided by minus 2, minus 2 cosec squared t. And it doesn't say in a particular form. Could have left it like that, or could have simplified this. I'm just going to show you. The reason it's worth simplifying is because I've read part B. So I've got 4 sine t cos t, got minus 2 over sine squared t. Well, this minus 2 cancels out with this to leave us with the minus 2 here. This sine squared t is going to go to the top, and so we end up getting minus 2 sine cubed t cos t. Does that make sense? Are you happy with that? So first we can work out m from the gradient. So it's going to become minus 2 sine pi over 4 to the power of 3 cos pi over 4. And so just ensuring the calculator is in radian mode, or if you convert that to degrees and do it, same thing. So if I put it into a shift setup, angle unit, radians, minus 2 times by sine pi divided by 4 squared, no, cubed, times by cos pi divided by 4. So you should have got a gradient of -1/2. Can you please verify that in the chat? So we've got m equals -4. Now we also need a pair of coordinates that this goes through. We're told x equals 2 cot t. This was -2. This is positive. This is definitely positive. So the trig terms are positive. When I multiply by -2, the answer is going to give me a negative. So can you just check that, please? Now, x is 2 cot t. So that is the same as saying 2 over tan pi over 4. Now, tan pi over 4, you should know, is 1. So it's 2 over 1, which is 2. And y equals 2 sine squared pi over 4. So for that, I will use the calculator just because I don't want to make a mistake. 2 times by sine. Actually, I want another bracket here. Sine squared. And I'm getting y equals 1. Did you get those two coordinates, please? Please let me know. So now we know that this line passes through 2 and 1. And so the equation of the line is y minus 1 equals minus a half x minus 2. And that's it. We don't need to simplify it. We can do. No real benefit in it though. Okay, any questions there? Y equals 2 sine squared t. So what can I do with this? Now, I've told you before that to find the trig identity linking this and this together. That's what we are trying to do. So cot, do we know any identities with cot? There's only one really. Cot equals cos over sine, but the thing with that is cot t equals cos t over sine t. I've still got t's on both sides. That's not helpful. And then there's the other one we know, 1 plus cot squared t equals cosec squared t. Now, which one of these are we going to use? Especially given this is sine squared. It has to be this one. Okay, so now let's see if we can use this to essentially eliminate t. 1 is a constant, can't do anything with that. Plus cot squared. Now, if x equals cot 2 cot t, what is cot t? It has to be x over 2 equals cot t. I should have written t there. So now cot squared is going to become x over 2 squared. Are we happy with the left-hand side there? Now, I need to get cosec squared. How can I get cosec squared from y equals 2 sine squared t? Well, we can say y over 2 equals sine squared t. And if I want cosec squared, which is the reciprocal of sine squared, I'm going to do the reciprocal of the right-hand side. So therefore, cosec squared t from that becomes 2 over y. So now I can replace cosec squared t with 2 over y. Does that make sense? Are you happy with that? And so now, is that my answer done? Is that my answer done is my question for you. That's a silly question. Why not? Because it says we need to make it in the form y equals f of x. We need to make y the subject. So now, I want you to make y the subject. And let me know what you get for that, please. So if I do it in 2 steps, if I multiply y across, 1 plus x over 2 squared equals 2. So y is therefore going to equal 2 over 1 plus x over 2 squared. So that's right. So that's the same as saying 2 divided by 1 plus x squared over 4. Same as saying 2 divided by 4 plus x squared over 4. And now I can divide by changing this to times and flipping this upside down. So we get 8 over 4 plus x squared. And there is the equation in that form. Okay, does that make sense? Are we happy with that? Now, are we still done with the question? No, we aren't, because it's saying state the domain on which the curve is defined. So to work out the domain, we need to sketch x against t. Okay, so here, if we think about it, we need to sketch x equals 2 cos t, not cos t, cot t, in the range of t is strictly greater than 0 and less than or equal to pi over 2. So cot t, the base graph that I'm going to sketch first of all is cot t. X now is on the y-axis, t is on the x, and cot t looks like this between 0 and pi. But we only want it up to pi over 2, so therefore we are going to get rid of this bit here. Then, so this is cot t. Then I'm going to sketch x equals 2 cot t. What transformation has taken place there on the cot graph? This is pi over 2 here. We are multiplying y values by 2, which we can't show. So simply it's going to be the same graph. This is still pi over 2. This is t. And this is x. And then we said that the domain is allowable x values. And allowable x values means looking at the height, because x-axis, x is now on the y-axis. So allowable height is this. Lowest height is 0, goes up to positive infinity. Is pi over 2 included? Yes, it is. So therefore 0 is included. Okay, so therefore we're going to say x is greater than or equal to 0. Because at pi over 2, x is 0. Does that make sense? Any questions there? Where is this curve going across the x-axis? anything across the x-axis, y equals 0. So therefore, we're going to make 1 minus 2 cos t equal to 0. And so we get cos t equals a half. And we are solving in the range of 0 to 2 pi. So CAST in A and in C, T is 60 degrees, next one 300, convert that into radians, pi over 3 and 5 pi over 3. The rest is not relevant right now. Right, okay, last question then. I want you to have a go at this, please. Have a go at 4 part A. Let me know how you get on or what you're trying if you're unsure. X equals sine t, dx by dt equals cos t. There's my helpful hint. Y equals sine of ax plus b. Oh, it's not ax plus b, it's t plus pi over 6. What's going to be the differential of this, please? Dy by dt the coefficient of t here is 1. Right, so when I differentiate this, I'm going to get 1 cos t plus pi over 6. And that's it. And we don't need the 1 there, it's just cos t plus pi over 6. Because we would generally multiply by the differential here. If you remember, this turned to a cos ax plus b. But if a is 1, then multiplying by 1 is not going to change anything. And that should now help you complete part A. Over cos t. I've got dy by dx. Now it tells us t equals pi over 6. So all I need to now do is to work out my gradient. M of tangent is going to be cos of pi over 6 plus pi over 6 over cos of pi over 6. And so the numerator is a half, and the denominator is root 3 over 2. So this becomes root 3 over 2. And so we get 1 over root 3, or root 3 over 3. What else do I need to work out? The equation of a tangent. Can you please talk me through that in the chat? To work out the equation of a straight line, I need the gradient, which I've worked out, and I also need a pair of coordinates. Now, how am I going to get the pair of coordinates? By substituting t equals pi over 6 into this equation. So x equals sine pi over 6, which is a half, and y equals sine pi over 6 plus pi over 6, which is root 3 over 2. Now that we have the gradient, we know m is root 3 over 3. We know the coordinates are a half and root 3 over 2. We can say y minus root 3 over 2 equals root 3 over 3 x take away a half. And there is the equation of the tangent. Does that make sense? What's this point of intersections? So let's have a look at this. X equals sine t. Can't do anything with that as it stands. Y equals sine t plus pi over 6. Or we can do something with that. We can use the addition rule. So we've got sine t cos pi over 6 plus cos t sine pi over 6. And we can simplify that further. Sine t multiplied by root 3 over 2 plus cos t multiplied by a half. It's starting to look closer to the thing that we want. I'm just going to write this so that we've got the numbers at the front. Right, can you please tell me what I'm going to do now? What can I do now to get closer to the answer? At least one thing. I want you all to tell me, please. Well, we know sine t is x. So anywhere I see sine t, I can replace in x. So I get root 3 over 2x, which looks very similar to the bit at the front here. Root 3 over 2x, but there's no cos t. How am I going to replace cos t? So this is a half, and now I need to replace cos t. There's a problem. So if I know x equals sine t, sine squared t is going to equal x squared. And if I write this as 1 minus cos squared t, still the same thing. I make cos squared t equal 1 minus x squared. And if I I square root both sides, I can now write cos t in terms of x. And so now I can replace it in here, because we know what cos t is. We can write this as 1 minus x squared. Does that make sense? Are you happy with that?